Hey y'all, today we're going to talk about some more examples of compositions of functions. I know that can be really confusing at first, so we're going to just go through and work a couple of examples. So to start us off with, let's look at some examples, and I have the two different ways of writing composition of function up at the top so that we can refer back to it. But let's look at the function f of x equals 3x squared plus 2x minus 5, and g of x equals 4x minus 7. Okay? So we're going to look at these two functions. And what we're going to do is first we are going to find f composed with, I'm switching pens a lot, composed with g of 3. Okay, we're going to find f composed with g of 3, or f of g of 3. Okay, two ways of saying the same thing. So when we do that, if we refer back to what we have up here, that means that we're going to do, again, f of g of 3. Okay, I'm trying to color code this to help you out. So what that means, when we go to do f of g of 3, it means we're going to take 3 and we're going to plug 3 in to our function g. Once we plug 3 into our function g, we're going to have g of 3. Okay, so then once we get g of 3, we're going to plug that in to our function f. And what we get after that will be f of g of 3. Alright, so that's the pattern we're going to follow. So kind of working our way out, we start with the 3, plug it into g. Once we get that, we're going to plug that out into f. Alright, so starting with the 3, we're going to do g of 3. So g of 3 means we take 3 and we plug that into our function g of x. So g of x is 4x minus 7. So we're going to do 4 times, we're replacing x with 3. So 4 times 3 minus 7. Alright, from here we're going to simplify to get g of 3. So 4 times 3 is 12. And we bring down our minus 7. So we get 12 minus 7. Then 12 minus 7 is 5. So g of 3 is equal to 5. So what we're going to do now is up here where we have g of 3, we now know that g of 3 is equal to 5. So instead of now that we have g of 3, we move on to the next step. So we plugged 3 into g and got g of 3. Now we're going to plug g of 3 into f to get f of g of 3. So when we plug g of 3 into f, we now know that g of 3 is 5. So instead of doing f of g of 3, you can think of it as we're doing f of 5. Alright, so I went through and I just replaced all of the g of 3's with 5. So we're going to do f of 5. So when we do f of 5, whatever's in the parentheses is going to replace our variable. So we have 5 in the parentheses. So 5 is going to replace our variable in our function f. So instead of 3x squared plus 2x minus 5, we're going to change both of the x's to 5. So 3 times 5 squared plus 2 times 5 minus 5. So now that we have 5 plugged into our equation for x, we're going to simplify what we have here. So 5 squared is 25, so we have 3 times 25 plus 2 times 5 minus 5. Then 3 times 25 is 75 plus 2 times 5 is 10 minus 5. And then finally, 75 plus 10 would be 85. Minus 5 is going to give us 80. So f of 5 is equal to 80, but remember, f of 5 was f of g of 3. So what we've actually found when we get this 80 is our composition, f composed with g of 3, or f of g of 3. So 80 would be our final answer here when we're doing f composed with g of 3. Composition of functions can also be done in the other direction. So let's use these same two functions, but let's do things in the opposite direction. Okay, so now let's look at, instead of f composed with g, let's go backwards. And let's do g composed with f. So we're going to do g composed with f of, and let's use 3 again. So g composed with f of 3, but really you could do this with any number. So g composed with f of 3 is the same thing as saying we're going to do f of, not f, sorry, ignore that. Let me fix that. Where is my, there we go. Ignore me there. See, sometimes it gets confusing. All right. We're going to do g of f of 3. All right, I messed up for a little bit there. I was looking over at what I had already done. So we're going to do g of f of 3. Okay, so g composed with f of 3, or g of f of 3. So again, we're going to create our little roadmap. So first we start with 3, so we start on the inside. We're going to take 3 and we're going to plug it into f. So working our way out, we go to f. Once we plug it into f, we're going to get f of 3. All right, so plugging 3 into f gives us f of 3. So then after f, we go to g. So we're going to take our f of 3 and plug it into our function g. And what we get out of that is going to be g of f of 3. So to start, we're going to start with the 3, and we're going to plug 3 into our function f. So we're starting by doing f of 3. And f of 3 means we take 3 and we plug it in to our function f, which is up here. So everywhere we have an x in this function, we're going to replace the x with 3. So we have 3 times 3 squared plus 2 times 3 minus 5. 3 times 3 squared plus 2 times 3 minus 5. Then we're going to go through and we're going to simplify this. So 3 squared is 9. So we get 3 times 9 plus 2 times 3 minus 5. Then 3 times 9 is 27, plus 2 times 3 is 6, minus 5. All right, and then finally, 27 plus 6 is going to give us 33. 33 minus 5 gives us 28. All right, so 28 is our f of 3. So we're going to come up here and replace f of 3 with 28. All right, so f of 3 is 28. So right here, again, we're no longer doing f of 3 because we know that is 28. And so now we took 3 and plugged it into f. When we did that, we got our 28. Now we're going to take our 28 and plug it into g. So we're going to do g of 28. So we're going to take 28 and plug it into our function g that we had up here at the beginning. So we're going to replace x with 28. So we're going to do 4 times 28 minus 7. All right, and I'm going to have to come do some scratch work over the side for 4 times 28. So 28 times 4, 8 times 4 is 32. 4 times 2 is 8, plus 3 is 11. So 4 times 28 is 112, minus 7, and 112 minus 7 is 105. All right, so now, again, we started on the inside. We started with 3. We plugged that into F and got 28, and we then plugged our 28 into G and got 105. So 105 is our answer to G composed with F of 3, or G of F of 3. All right, so that's composition of functions when you're plugging in a number. You can use the same strategy, though, if you're not plugging in a number at all, if you're just doing the functions. So let's do an example of that. All right, and I'm going to keep this up here for our reference. So let's do the functions f of x is equal to the cube root of x plus 1, and g of x is equal to x cubed minus 1. All right, so these are going to be our two functions, and we're going to do f of g of x. Or we know that that's the same thing as f of g of x. And so you can say it the same way, or you can say f composed with g of x. Okay? All right, so this time we don't have anything that we're going to plug in for x. So instead, our roadmap, just like we had our roadmap for the last problems we looked at, instead of starting with a number that we're plugging in, this time we're just going to start with our variable. So we're going to take x, and x is going to get plugged in to our function g. Okay? When we do that, that's going to give us g of x. Then we take g of x and plug it into our function h. And once we do that, we get, not h, I don't know where h came from, our function f. I don't know if I can turn that into an f, hang on. We take g of x and we plug it into our function f. All right, and so when we do that, we get f of g of x. All right, so we start with plugging x into our function g. So if we come up to our function g, we already have x in place of our variable, so we don't really need to do any substituting here. So we already know g of x. So x going into g gives us g of x, and g of x is our whole entire function up here, so x cubed minus 1. So when we plug g of x in for f, really we're plugging in x cubed minus 1. All right, so f of g of x means we're going to do f of x cubed minus 1. So let's do that. Let's do f of x cubed minus 1. So in our function f, we're going to replace our variable x with x cubed minus 1. So we still have our cube root of, but instead of x, we're replacing that with x cubed minus 1. So this right here, x cubed minus 1, takes the place of x, but we still have the plus 1 at the end. All right? So we have the cube root of x cubed minus 1 plus 1. So now when we simplify this, we start by simplifying what's inside of the cube root. So we have x cubed minus 1 plus 1. Well, negative 1 plus 1 is 0, so we would just have the cube root of x cubed, We could write plus 0, but writing plus 0 doesn't change anything, so we just leave that off. And then the cube root of x cubed is going to give us just x, because a cube root and a power of 3 are opposites of each other. So the same way -1 plus 1 kind of cancels out, our cube root and our cube are also going to cancel out and leave us with just x. All right, so that was f of g of x. So now we know f of g of x is equal to just x. All right, so when we do f of g of x here, we got just x. And we could also do this with the opposite direction. So instead of f of g of x, we can do g of f of x. I'm sorry, it takes me the longest time to write this out with the different pens. So we're going to do g composed with f of x, or g of f of x. Right, and again, if we go back to our roadmap like we have over here, we start with what's on the inside. So we start with x, and we're going to plug x into our function f. So working our way out. And when we plug x into f, we get f of x. So then we take f of x and plug that into our outside function g. And so what's going to come out of that is going to be g of f of x. So to evaluate this, we start with x by plugging x into f. Well, if we come up to our function f, we've already plugged x into our function. X is already the variable here. So there's not really anything to do to plug x into f of x. So we can go straight to f of x. And f of x is the cube root of x plus 1. So where you have the cube root of x plus 1 is equal to f of x. So now when we when we plug it into g to do g of f of x, we're plugging in the cube root of x plus 1. So we're going to plug in the cube root of x plus 1 into our function g. So now we're doing g of the cube root of x plus 1. So this is the same as g of f of x. So since this is inside of our function g, that tells us that this is going to replace our variable. We're going to substitute the cube root of x plus 1 in for our variable x in the function g. So when we do that, our x cubed is going to become the cube root of x plus 1 cubed. And then we keep the minus 1. So now we're going to go through and we're going to simplify this. So when we have the cube root of x plus 1 cubed, again, a cube root and a cube, or a power of 3, are opposites of each other. So those are going to cancel out. So that would leave us with just x plus 1, so just what was inside of that cube root. And then we can bring down that minus 1 that was afterwards. Now 1 minus 1 is 0, so we get just x. We could write plus 0, but again, writing plus 0 or minus 0 doesn't change anything, so we just leave it off in algebra. So we get x. So x is g of f of x, or g composed with f of x, for this pair of functions. So what's interesting about these functions is that when we did the composition of functions here, when we did f of g of x and g of f of x, we got the same answer both times. And that doesn't always happen with functions, but sometimes it will with special functions like these. All right, so hopefully those couple more examples helped clear things up, but if not, let me know if you have any questions, and have a great day.